There we go. Okay, so we're starting off today with Henry's Law. So you guys put your Henry's Law explanation into a sentence in Pear Deck. So now let's just try a couple problems. Again, really for all of the laws that we encounter in this chapter, the really important thing, the really important takeaway you want to get out of all the practice and the repetition is the relationship. Is it a direct relationship? Is it an indirect relationship? Is it an exponential relationship? How do the variables affect each other? Because most of the time, that's the kind of question they're going to ask you on an AP test. They're not going to have you solve very many of these equations. It's more of a relationship thing. So with that said, sometimes actually doing the calculation helps us to grab a hold of that relationship. So let's try these two problems. Go ahead, try them, put your answer into Pear Deck, and then we can talk about points of confusion.
So when it asks us to calculate, how do we know that it's Henry's Law? I know we know that right now because we're doing Henry's Law and that's what we're focusing on, but how do we know that that's what we're trying to find?
Yeah, really good question, Lainey. So here's how I would process through this problem. I would read through it and kind of underline and circle, right? So they're going to calculate. This is what I'm calculating. I have a partial pressure of 4. I have a K that, if they say it's the Henry's Law constant, that should give you a clue, right? But if they don't say that, let's see, what is this? Moles per liter atmospheres. And then they're asking me for concentration. So here's my list of what I have and what I'm trying to find. Concentration, partial pressure, and a constant. So what relationship do I have between partial pressure and a constant? And so you're either going to have a concept or you're going to have a law. So making a list of things you have and things you're trying to find, and sometimes even putting in a statement okay, I'm looking for a relationship between partial pressure and concentration.
Okay.
That's kind of how my brain works.
Okay.
Also, while we're on the topic, it might be worth pulling out your reference sheet at this point in time and looking to see if Henry's Law is on there. Because if Henry's Law is on there, then you don't have to remember that it's a direct relationship, because the actual law should tell you that. If Henry's Law is not on there, then you do need to remember this relationship. And this might be a good point in time. I don't know if we've talked about this before, but if you have a notebook that you are kind of keeping track of, I don't know, outlines or in-class work or practice problems, it's worth taking the very last page and making it a things to review the week before the exam kind of a deal. And if I were you, I would put Henry's Law on this, because Henry's Law is used in this chapter to relate partial pressure and solubility. It might be used in gases, but this might be the only time we actually see this relationship. And if it's not on the reference sheet, I mean, the chances of me remembering Henry's Law or this relationship in May is slim to none, right? So I would write it on this last page, kind of give it a title of things I should review, right? And then maybe you can have little boxes per unit, and I would put Henry's Law in there because it's not something we reference constantly, like Coulomb's Law. Coulomb's Law comes up and up and up and up and up. By the end of the year, Coulomb's Law should be written on your heart. Henry's Law, not so much. So it might be worth setting aside a review page for you. It's also worth showing you my notebook. It's my new favorite notebook. Everything is popsicle. It's a good motto for today. And it smells like grape. Anybody stressed out about the election today? That should have been our warm-up. What is everyone doing to keep yourself mentally stable and sane? What are you doing to grab onto wellness in the middle of election stress today?
I have a question.
Yeah, I'm ready.
So, when we use Henry's Law, it, talks about how K, changes. How do we know, what K is?
Yeah, good question. So, you're either going to have to be given K or you're going to be solving for K. So if you're given K, then you're solving for one of your other two variables. If you're not given K, then you have to be solving for K. They're not going to ask you to pull K out of your boot and use it. Another good topic for this practice problem. Question 1 on this slide and question 2 are both referencing the same context. So how can we be certain that K doesn't change? Why can we use the same K for both? Any thoughts?
Is this the constant and it's the same molecule that you're using?
So it is the same molecule, right? If we switched molecules, we'd have to switch it. That's true. Yeah. But Sydney typed into the chat, the temperature is the same. So as long as they give you a consistent temperature, you can use the same K. And as long as they don't change the molecule on you. That's true. If they changed the molecule, your K would change. Yeah. Okay, so on the top one, you should get something like concentration equals 0.1. That's a 1. 24 liters. Oh no, moles per liter. Good heavens. Let me just try that again. 0.124 moles per liter. And on the bottom, you should get something like 9.3 times 10 to the negative 6-ish moles per liter. Okay, and it looks like we got close to that. The variations I see in the answers that you guys submitted were powers of 10. So this is not one that I would expect you to do without a calculator, although you could probably do the first one without a calculator. Actually, you could probably do both of these without a calculator. The second one I feel like would be harder. But these came from a book, so they're designed to be used with a calculator. So if you did not get the same powers as I did, let's figure that out. I'll give you 30 seconds to figure that out and ask questions. Okay, some of you have adjusted answers. Does that mean it makes sense? Does that mean when you go practice this on your own, you're going to be able to do it? Does that mean you have a question? I don't know.
First one, I multiplied 3.1 times 10 to the second times 4.
Yep. Yeah. That's exactly what you're supposed to do. Yep. Because 3.1 times 10 to the negative 2 is our K. 4.0 is our P. And this is, what is it? Moles per liter atmospheres. This one is atmospheres. So it leaves us with the correct units. Yeah, you got it. And the bottom, you just do the same thing. 3.1 times 10 to the negative 2 times the concentration, which is a little bit messier. So 3.0 times 10 to the negative 4 atmospheres. Why is it 9.3? It should be 9. Oh, yeah, 9.3. That makes sense. So it's kind of a plug and chug question, as long as you can use, you know which equation to use. As long as you know the C equals KP. Did anyone look at your reference sheet? Anyone figure out why, if Henry's law is on your reference sheet or not? No. Callie, try using parentheses. I would guess that you're not using parentheses and your calculator is reading is multiplying 4 by the 10 raised to the negative 2 before it multiplies by 3.1. Good question, Claire. What would you do if they were different temperatures? You would have to recalculate K. So if the temperatures changed, they would either have to give you a new K or they'd have to give you enough information in the second one for you to calculate a new K. Also, last note before we go on in this one, is everybody aware of your E button on your calculator? Not your E, your lowercase e button, your uppercase E button. If you are using a scientific calculator, let me go grab one because I don't have one with me. All right, if you're using a graphing calculator, there's an E button on this one. It is right there. It's right above the 7 it's the comma, and it's above the comma, and mine is like light purple. And so in order to get to it, I have to click second comma. If you use that button takes the place of times 10 caret. That is the EE button, or the E button, is equal to those 4 buttons put together. But the other thing the E does, so not only does it save you like button pressing, the other thing it does is it locks your 2 components together. So if you were to type in like 3.1 times 1 0 caret negative 2, the way your calculator is going to read this is that, let's see, the 3.1 and the 10 to the negative 2 are 2 separate values. If you type this in as in 3.1 E negative 2, then what the calculator reads is that this whole thing is 1 value. And so your calculator on the top, what your calculator will do is if you take this and you multiply by 4, depending on the calculator, it'll group it differently. So it might group these 2 first, and then it'll multiply by 3.1, which is not necessarily the order that you want the calculator to process. If you do the bottom one, then your calculator reads this as 1 value multiplied by a second value. And so you don't have to deal with this order of operations thing that you have to deal with in the first one when your calculator reads it as 3 separate values. So know and love your E button, but don't ever write your E button on a test. If you ever write a number, it should never have a big E in the middle. You should write out times 10 to the negative second. The other thing is you should know and love your parentheses. When in doubt, add parentheses, because your calculator is not going to do PEMDAS for you. You have to force it into the order that you want it to multiply, and that becomes a really big deal in AP chemistry. I would say 75% of the errors on tests are because you punched it into a calculator wrong. So be careful of that. Okay. I'll get off my calculator pedestal and we'll do the next one. I'm sure we'll have that conversation a second time at some point in time this year. Okay. Here we go. You're calculating mass percent and mole fraction of sulfuric acid. So this question comes right after this question. So this was the last question in the video where we went over like what all of these values are. And so the next step in your book is converting between these values. So like I said, this is a logic game. It's a puzzle. It's a challenge. So for those of you who tend to get frustrated off the bat, like, I don't know where to start. I don't know what they want me to find. I hate this question. Now is your chance to take a deep breath and repeat to yourself, I love challenges. I love challenging things. I love trying hard things. I love trying new things. Just say that to yourself a couple times and then try this question because it's very much a puzzle. So I'm going to give you like a minute or 2 to try this. See how far you can get. My one word to the wise is break out your units. So for example, they tell you 3.75 molar sulfuric acid. Don't use molarity. Use moles per liter. When you break out your units, that's going to help you. Okay, so go ahead, try this for a couple minutes. Ask me when you have a question. Okay, here's another hint. If you haven't written something down yet, do it. Put your pencil onto the paper and write down as many things as you possibly can. I'm going to run and get some water. How's it going? Okay, give me feedback on the chat. Let's say 1 is I'm stuck. A 2 is I'm working on it. A 3 is I have an answer. Okay. Okay. So on this, we're calculating mass percent and mole fraction. They give you molarity. They give you density, right? So my favorite go-to is just write out what you want and see if you can get there. So mass percent is going to be mass or grams of sulfuric acid. And I'm going to write, instead of writing H2SO4, I'm going to write HA to save myself some work. So I want mass percent, which is going to be mass of HA over mass of your solution. So that could be mass of HA over mass of solution total, or mass of HA over mass of HA plus mass of water times 100. Okay, so I'm looking for those two things. I'm also looking for mole fraction, which is going to be moles of HA over moles of solution, or moles of HA over moles of HA plus moles of H2O. Okay, so those are the two things I'm looking for. I have 3.75 moles of sulfuric acid over 1 liter of water. Now remember, that's not an actual amount. That's just a ratio. So I can use that if it's helpful to me as an actual amount, or I can change that. I can multiply that as a ratio. Okay, I'm also given 1.230 grams of HA over 1 milliliter of solution. Oh, that top one's not water, it's solution. Okay, so here's what I have. Now notice all four things, the two that I'm given and the two that I want, they're all ratios. So the power of a ratio is you can pretend like you have any amount and it doesn't matter as long as you keep the ratio the same. So I could pretend that I actually have 1 liter of solution because it doesn't matter how much I have. All four things are ratios. All right, so can I get from something that I have to something that I want? So could I convert? I have moles of HA already. Could I convert liters of solution into moles of solution or grams of solution? Is that possible? That is possible. So what we're going to have to do, we're going to have to pretend that we have a set amount. We're going to have to pretend that we have a liter of solution. I mean, you could do it 1 liter or 10 liters or half a liter or 100 liters. It doesn't matter because it's a ratio. But if I assume that I have 1 liter of solution, then everything just stays the same. So let's do that. Let's assume I have 1 liter of solution and then see if I can convert to these other things. So 1 liter of solution, how much of that do I have in grams of acid and grams of water? Let's do that first. Let's go from here to mass percent. So I'm going to go... So 3.75 moles of acid, I want to convert out of moles of my acid into mass of my acid. So 1 mole, and then my molar mass is going to be 2 hydrogens, 1 sulfur. Need a closer periodic table.
It's 97.6 grams per mole.
Say that again.
It's 97.6 grams per mole.
I got 98.0. That's close though. Let me do it one more time. Yeah, I got 98.079. Okay, so that would give me 367.86 grams of sulfuric acid in the numerator. Okay, so can I get from a liter of solution to grams of solution? And I can do that using density. So I'm going to go, yuck. Okay, liters to milliliters. Milliliters to grams. Okay. So that's 1230 grams total, water and acid. And then we can get to mass percent, right? 367.86 divided by 1230 times 100. My mass percent is 29.9% sulfuric acid. Who beat me there? Ooh, a couple of you. Nicely done. Again, watch your powers of 10. Say it again.
I'm kind of confused about when you did the first kind of conversion up there with the 3.75 moles per liter and then the molar mass. The liters didn't cancel out, did they? When you know what I mean? Like
right.
The moles did, but
nope. I am ignoring the denominator and just converting the numerator.
Okay.
I was just lazy. Instead of like rewriting it and converting it out, I just kept it on top of the fraction. So that like 3.75 times 98 over 1, that's all in the numerator. I'm just completely ignoring my denominator right now.
Okay.
And then I did the same thing down below too. I'm completely ignoring the numerator now, and I'm just converting the denominator out of liters into grams.
Okay.
Yeah. Okay, so if you, I mean, we've only done half the problem at this point in time, but if you were to take your this problem and write out, okay, step 1 I do this, step 2 I do this, step 3 I do this, it wouldn't be a very helpful sequence because any question you come up against this, like this, is going to be totally different. So, if you're going to write a sequence to solving a problem like this, it would look like a generalized sequence to solving a lot of different chemistry problems, right? A, list out what I have. B, list out what I want. C, look for anything that I have that can be used to get to what I want. If I don't find that, then list what I have in greater detail, right? Instead of saying moles of acid over moles of solution, can I write that out in greater detail? Moles of acid over moles of acid plus moles of water. Can I separate that out? So it looks like a generalized hints for solving a dimensional analysis problem, right? This is like a dimensional analysis problem on steroids, basically.
So we found 307.86 grams of the sulfuric acid, and then that was in 1 liter, and then we found 1,230 grams of sulfuric acid in a liter?
No, so that's a 367, by the way, if you're not getting the same numbers I am. That's because that's a 6. So in the yellow, I have found, instead of saying I have 3.75 moles of acid, I just converted it to grams. So I have 367 grams of acid. And then in the green, what I did was I know I have that much acid per 1 liter of solution, right? And solution is acid and water together. So 1 liter of solution, I converted that into grams of solution. So if I take the volume of solution I have and I multiply it by the density of the solution, what do I get? I should get mass of the solution, right?
Why not mass of the sulfuric acid?
Well, because we haven't really stopped to figure out what percentage of that solution is sulfuric acid and what percentage is water. We haven't really stopped to figure that out yet. Right now, I just know I have a liter of some mixture in a bottle, And I know what the density of that mixture is, but I don't know what percent is acid and what percent is water.
So under the green, where you put 1.23 grams of HA, is that HA not actually the acid? That HA is the solution total?
The 1.230 grams of HA is your acid. And then, but that's in 1 milliliter of your solution.
Oh, got it.
Yeah, that's not total. That's not in my beaker, because remember we said in the beginning, we're going to assume, here, I'll write at the top, we're going to assume we have 1 liter of solution. So this density thing at the bottom, this measurement of density that they give us, that is not per 1 liter. It's per 1 milliliter. So it's related, like we could figure out how many grams per liter, right? But it's not equivalent yet.
Right. Okay, that makes a little more sense.
Okay. Okay, so now to go to mole fraction. So we have moles of acid, we just don't have moles of solution. And because our solution's a mixture, right? It's a mixture of acid and water together. It doesn't have 1 molar mass. It has 2 molar masses mixed together. And so I definitely have to separate out the 2 things before I can figure out moles of acid and moles of water. So I'm going to erase a little bit that's on the board right now. And I'm sure there's a bunch of different ways that you could do this. So I'm going to do it down here at the bottom. I have figured out the 2 in the same unit. I have figured that out in one place. In molarity, I have 2 different units, moles and liters. In density, I have 2 different units, grams and milliliters. But in mass percent, I have the same unit on the top and the bottom. I have grams on the top and grams on the bottom. And so I can use this to my advantage, right? I can say I have, 367.86 grams of my acid. So I know I have 367.86 grams of my acid plus water that makes up my solution. So what I really need to figure out right now is how many grams of water I have. And if I have 1,230 grams total, then I can subtract those to get grams of water. So total amount of mass minus mass of acid is going to give me the mass of my water. 1230 minus 367.86. So this is 862.14 grams. And now, since I want mole fraction and not a mass fraction, I have to just convert all of these things into moles. Which, for the sake of time, I'm going to do quickly. Okay. So dividing 862 by the molar mass of water gives me 50.3 grams of water. And now I can convert molar mass. I mean, I can calculate mole fraction. Point 0.694 is my mole fraction. Okay, that is time. That's class for us now. Just one last thing about this question. This is kind of like a puzzle. If you were to watch someone do a puzzle, it doesn't do a whole lot for your ability to solve a puzzle, right? I mean, it kind of gives you some starts and some leads and some things to do when you're stuck, right? But in order to learn how to do a puzzle, you really have to go do it yourself. And there's a bunch of these in the book. So again, you got to play with it. Take a deep breath, play, get as far as you can. And then when you get stuck, go talk to someone about it. And instead of just saying, how do I do number 35? Say, this is where I can get this part, but I can't get this part. How do you get the bottom part? Or something like that. Giving a specific question where you are stuck is going to be the most helpful thing you can do. Okay, I'm going to stop this recording and then I'll stay on for questions or discussions that you guys want to have.